Good morning, students. I am Munsi Rasidul Islam, Assistant Professor of JIS College of Engineering, Department of Mechanical Engineering. Now, in this class, we have discussed about the different design consideration that I told the previous classes that there's some design consideration you have to consider during the designing of any mechanical components. But some points are there that points I already discussed in the last classes. So now in today's classes the topic is factor of safety and, and mechanical properties. So factor of safety, that is actually one simple word, but its application is vast, and its short form is FOS. So in this factor of safety calculation, so most of the problem and most of the design based on the ultimate stress or yield stress, ultimate strength or yield strength. So ultimate and yield strength is not considered for the actual strength of the material. So for that calculation, first of all, you have to consider the actual permissible stress or allowable stress. In designing problem, most of the design calculation, ultimate stress and yield point stress is not considered as a perfect data calculation. So if you get the perfect data for designing any mechanical components, you have first consider or you have first to convert the yield point stress or ultimate stress to the working stress or allowable stress. So first of all, what is working stress? That point you have to know, and then factor of safety, how it can be calculated. It is I can express you that, and the factor of safety is different for the different type of material. It it may be vary from material to material. Now, so for first case, what is working stress? Now, for working stress calculation, working stress is also known as permissible stress or allowable stress for any type of material for use of machine and mechanical components. It is also known as the design stress. So, working stress is termed in three shapes. Number one, allowable stress. Number two, permissible stress. Number three, design stress. So in these three terms, actually one meaning, that meaning is working stress. So the working stress is obtained by easily available by if I divided the ultimate stress by effect to the yield point stress, ultimate stress or the yield point stress, as may be noted that it is actually a point where the total load can be calculated as a maximum withstand load. Maximum withstand load means that is actually the limit of acceptability, where the maximum load absorbing capacity of any material is just up to the max. That is actually the point where the maximum limit is to be considered. That point is actually the ultimate point. And allowable point means that permit. Allowable point means the level of permission where the design is allowed to behave just like a normal situation. That is actually the working stress or allowable stress. So suppose for example, suppose one a problem, if I given if I giving you a problem, that problem, suppose the ultimate stress is for 600 MPa, and the factor of safety is suppose 3. So for that cases, the working stress or permissible stress will be the ultimate stress divided by the factor of safety. That is actually case of the working stress, how it can be calculated. So now next point we can concentrate the stress strain diagram. But one question will arise uh, for topic is factor of safety, but why we can study the uh, stress strain curve? Because all the things that I explain, all the things are correlated with each other. So if you do not understand the stress strain curve in proper way, you cannot solve any type of stress strain related problem. So so for the stress strain curve, that is actually stress y-axis is stress and x-axis strain. So first draw a diagram. That diagram is actually plotting with some center distance, and that is up to the here are the 5 points are there: P, E, Y, U, F. Here P is actually termed as the proportional limit, E is called elastic limit, Y is called yield point stress, and U is called ultimate stress, and F also known as the breaking stress. So up to the point where the P is located, up to that point the material behave just like a normal situation. But up to the point P, the Hooke's law maintained properly. Hooke's law maintained properly means, suppose in Hooke's law we know that within elastic limit, the stress is directly proportional to the strain. But we cannot explain properly. Within proportional limit, that should be the perfect definition of Hooke's law. So up to P point, we can consider the value of safe value of the material where the material has no changes. So that point is considered as a proportional limit point. And if I see in the dotted line from y point to the x point, that is actually behave just like a one straight line, and that is applicable only for the ductile material. Now ductile material. So that is the curve, and the values of stress strain determined from the tensile test, and that can be plotted obviously in stress strain curve. And that stress strain curve for any mechanical engineer you have to know properly. Otherwise, in each and every field of the mechanical engineering where you going to get a job, uh, that that diagram means stress strain diagram for ductile material and also the brittle material you have to know. Now next, that is actually a diagram. That diagram is differentiation between the ductile versus brittle. If you see the diagram, that diagram is actually plotting in the left hand side. There are three regions are there: uh, elastic region, strain hardening, and necking. And finally, at the right hand side for the brittle material, there will be no neck formation will be there. Only two phase will seen in the test when brittle material can be tested in the machines. So two phase are there. Only one phase is elastic region, another phase is strain hardening. But in first cases in ductile material, there will be up to E point. There will be elastic region property will be present, and in up to y point it behave just like a normal stress strain conditions. Next, up to yield point stress, up to yield point stress, that behave just like a material that you hardening the total material properties of the total material conditions of the phase transformation, phase transformation. And last one is neck formation. From E to F, neck will be created or neck will be formed, and in this situation the material have a tendency to break up the original shape, to break out the original shape with the some certain elongation, with some certain elongation. That is actually the case, and that is actually the difference between ductile material versus brittle material. Now, next, definition of factor of safety. So, we already know that factor of safety is defined for the defined material. Now, for the case of factor of safety, that is short form of FOS, and it is actually defined as the ratio of ultimate strength of a member or a material, of one piece of material to the as the actual working stress or maximum permissible stress when it can be used. But one consideration is there, because because the factor of safety is basically a constant value, and that unitless value, and that value may be changes as per the material property will be changed. So if material property change, obviously factor of safety will be changed. So it is actually a variable number and unitless number, and it is defined for ductile and brittle material. If you see the next slide, now factor of safety consideration for ductile and brittle material. Now for ductile material, factor of safety is defined. It is actually the of ratio of yield point tensile stress to the working, sorry, to the working stress, that is called in the factor of safety for ductile material. So factor of safety is defined as the yield point stress to the working stress. Now for the next case, for brittle material, it can be considered as a ratio of ultimate stress to the working stress. Both the cases, the factor of safety value will be a fixed value and a unitless number that will come, and that is actually the consideration. It is basically based on the different mode of mechanical properties of the material, and that is actually discussed in the next 2 3 slides. And in these slides we can see that that the most of the mechanical properties both are correlated with each other. If you do not understand the each and every point of the mechanical properties, you cannot go through the machine design of any part of the component, mechanical component. So that is the standardization of mechanical design, and we can standardize with some standard figure, and that is basically based on the standard notations that I use in different books or in different uh, website or different design data book. Now next is next point. All the points are mainly related with some mechanical properties, and that mechanical properties mainly mainly depends on um, some certain point of view with mechanical component of any type of design consideration. So First one is strength. Strength means that is actually in the it is actually a mechanical basic property. We know the stress, what is stress, what is strain, what is the Young's modulus, and now that point is strength. Strength is actually the total amount of load that can be used or that can be applied on a material. The material behave to protect the different mode of load applying, and that will observe in such a manner that the phenomena of the applying load with some resistance, that is called as a strength. And next, stiffness. Stiffness is actually it is actually defined stiffness or rigidity. It is actually a capacity of the material to the resist deformation under the various types of external loads that I applied that we apply in the material. So if elasticity is desirable in any case of the material or any other machine components, so the machine base or the structural frames on which parts of the automobile is assembled, so we must be consider as a stiffness of the material that may be suppose modulus of elasticity E, and the total level of the rigidity or stiffness of the material that will be discussed in the different mode. So that mode is actually, suppose bronze is used for the calculation of the stiffness or the rigidity. So for that cases, uh, bronze elasticity is approximately 11,000 square, uh, 11 1 lakhs 11,000 Newton per square meter, square millimeter. That is also less than the actual steel value. That steel value will be suppose 2 lakhs 220, suppose elasticity of the steel is less than of the bronze value. Bronze value of elasticity is less than the steel value. That is actually called as a stiffness. Now, toughness. Now, toughness is actually elasticity and ductility. Elasticity is actually a property. If I apply load, the material have a tendency to extend or uh, compress in any direction, but elasticity property is actually the property, a property of a material by virtue of which the material has a tendency to extend in any direction. That is, and if I apply, if we withdraw this load, the material will go back to the original shape, and that phenomena and that properties is called as a elasticity property. Now next, ductility. Ductility obviously the same type of definition, no difference is there. So that is actually the case of the material of any type of mechanical properties, and that is actually case. Next, brittleness. Brittleness obviously, if we apply load on a material, it is actually a property, obviously. As you know, the elasticity is a property of simply brittleness also be a property. Suppose a material is considered to be brittle if the specimen made of a material shows no or negligible plastic deformation prior to the fracture. That means fracture could be considered as a permanent deformation. So no deformation, no original shape will come. So that point of view, we can elaborate that brittleness is actually a material never ductile or sudden and abrupt fracture can happen in the process when the load is applied on the outside of the material or inside of the material. So that is actually case of brittleness, and that brittleness is based on the material behavior of the properties. Now, next point is creep. So creep. Next point is bulk. Next point is hardness. Hardness, obviously, a property of the material that can be used to the withstand of the load when the load can be drawn out into the wire, and in it is basically a property that protect the resistance when the material is used with some certain applying load, and that applying load may be some variable or maybe some sudden load. Next point is fatigue, and next point is fatigue. Fatigue, that means fatigue is actually a property of a material when the body or a material are in running conditions. Are in running conditions means uh, fatigue. No, sorry, toughness. Next point is toughness. Toughness is actually a property of material. It is to be said to be tough if it can absorb a large amount of energy before fracture. So, if resilience is the capacity of the material that can be withstand to absorb the total strain energy, and the release it when the loads are removed. When the loads are removed, that means toughness presents the total energy of the material, and that can be absorbed before fracture, and also total failure of the material takes place when the material are in the position of some torsion and twisting moment, and also bending or extension before the total failure occur. As tough materials should be able to withstand some mechanical properties to impact or shock loads. So we can and elaborately told you that the most of the cases of the material, or if any body of the automobile parts and the lower frame parts, that can be served during the process of applying toughness properties, and that is actually the case of toughness. And next point is fatigue. So fatigue property is considered when any body are in contact position, or are in running conditions with some velocity. Suppose with some RPM, revolution per minute. So if we apply load on any material, and material are in running conditions, so if the material have in any weak point of the throughout the section, so in fatigue in conditions, the material has a tendency to fail in the weak point of the section. So here are 2 points are there. One is fatigue, another is fatigue failure. So fatigue is actually the phenomena of which the material are in when are in material or body are in running conditions with some certain load, the material has a tendency to fail in weak position of the material, and that phenomena of the failure is called as fatigue, and the failure is called fatigue failure. So next point is creep. Next point is creep. What is creep? So creep is actually a time dependent, and it is basically permanent deformation of the body, and that body is based on the missing component of any type of material. So when the body is under the action of the load of any type of constant load or any type of variable load, it may be it may be exhibits the plastic deformation. in a continuous excessive way of the material. So over the period of the time, if we apply the load, the dependent the material properties and the magnitude of the load of the material may be vary upon the different types of mode of the failure. That failure may be in time variant or maybe in temperature variant. So time and temperature both are important for creating the creep failure. So that is actually the case of the material of any type of failure analysis. These are the say 8 or 9 points. That points and plasticity. Plasticity is another property of the material. That property is actually based on the material behavior, and it is actually happen when the material is brittle type, and if the applying load on the brittle material is over the ultimate point or over the ultimate observing point, the material has a tendency to the permanent deformation. Permanent deformation means if I withstand or if I withdraw the load, we cannot get the original shape of the material because the material will change properly with some certain limits, and that limits is actually considered as a permanent type. That type of property of a material is called as a plasticity property. And another point is to be considered, that is actually the energy absorbing capacity. So energy absorbing capacity, that means the machine elements that are primarily meant for the any type of withstanding load of the material, and that is actually the case of time bounding. And that time bounding is actually the time variable load, and that is absorb the energy during the loading system, and that loading system based on the criteria of different sudden load or shock load or impact load that is actually used. Now, besides this point, some important point also be there. Suppose these are actually the one slide. That slide I already suppose that slide I already told you in the previous slides, and here it is not used properly. Mm. So this point, that means the material also be important point, and that important material property, that means two types of material that we can use. One is metal and another is non-metal. And non-metal application in machine design is limited, but in metal type, both the types of the properties material are specially used. Suppose one is ferrous material and another is non-ferrous material. In ferrous material, most of the cases we can consider the material according to the carbon percentage of the material, and in non-ferrous material, some parts the design will be considered in case of non-ferrous type. So that is actually in the case of material conditions, metal non-metal and ferrous non-ferrous. So this point, up to this point, we can discuss all the detail. So just conclusion this slide, and now conclusion this chapter means lesson, that we know the from this lesson we know that what is the factor of safety, what are the different and consideration that I consider for the designing of any mechanical component. What are the different types of mechanical properties? Why? What are the difference between stress and diagram for the different material, etc., and the different mechanical properties? So all the things we have know this is in classes. Now next classes we can start with new lesson and new topic. Thank you.